Today I will be discussing part B of the PU Maths paper, which comes under question number 11. First of all, we'll begin with part A, that is with quadratic functions. The part A, let fx equals 8x squared plus 4x plus 2 lambda and gx equals x squared plus ax plus lambda for a and lambda are real, with a does not equal to 0 and lambda does not equal to 0. Then it says it is given that fx equals to 0 and gx equals to 0 have a common root alpha. So what does this mean? We need to substitute alpha to the given f of x and g of x. So let's start writing by substituting this common root alpha. So I'll start from here. F of x equals ax squared plus 4x plus 2 lambda. Then g of x equals x squared plus ax plus lambda. These are the two quadratic equations given. And then f of x says that f of x equals to 0 and g of x also equals to 0. That it says in here. Further, it shows that the quadratic equations f of x and g of x are equal to 0 and they have real roots. So note down that data as well. F of x equals to 0 and g of x also equals to 0. Then I told you before that we have to substitute alpha to each x term available in a quadratic function. Here for f of x I'll write a alpha squared plus 4 alpha plus 2 lambda equals to 0. Again for g of x I'll write alpha squared plus a alpha plus lambda equals to 0. This will be equation number 1 and this is equation number 2. So next what they say is it is given they have common root alpha. Find lambda in terms of a and show that alpha equals 2. Find lambda in terms of a and show that alpha equals 2. So in this case, we need to subject lambda. In order to subject lambda, it would be better if we could remove this alpha squared term. For that, it's better if we reduce 1 minus 2. Or else we can to remove the alpha squared term and to equalize and to reduce these two and subject lambda and get a value for it. I think one method, there are several methods that we could follow, but I will proceed by using 1 minus 2 into a, because here there's a term. So to fulfill that condition in here so that we can directly subtract, I will as the next step I will multiply equation number 2 by a. Then I will get a alpha squared plus a squared alpha plus a lambda equals to 0. Then I will consider this as another equation as 3. Then if I subtract 1 minus 3, then I can take I can cancel this 1 minus 3 this with this, and then I can take this alpha out. Then once I take alpha, it will be 4 minus a squared plus lambda 2 minus a equals to 0. Afterwards, I can to subject the term alpha, because we are asked to find a value for alpha as 2. So I'll simplify this as follows: alpha 4 minus a squared minus lambda 2 minus a. Then I can write this is the square of function. I can write this as 2 minus a and 2 plus a. This gives the product as this one. That's basic maths. And then equalize 2 minus lambda 2 minus a. 2 minus a, 2 minus a can be cancelled off, and then you can directly substitute this alpha, and then you get minus lambda minus 2 plus a as a answer. So now what can we do? Then we can directly come to a conclusion in here that a cannot be equal to plus or minus 2. Afterwards I will multiply the equation number 1 by a. I will multiply equation number 1 by a. Once I do so, equation number 1, if I multiply it by a, I can get it as a squared alpha squared plus 4a alpha plus 2a lambda equals to 0. Then I can reduce the equation number 2 multiplied by 4. What is my equation number 2? It's this. So if I multiply this by 4, I can take the same conditions as in this equation. For that I will write what I do. Each and every step I will be writing here so that it is easy to understand. Then here if I multiply equation number 2 by 4, that would be 4 alpha squared. 4 alpha squared plus 4a alpha. You see now the two middle terms were made equal so that we can subtract these two easily and subject alpha again. And 4 lambda equals 0. So if I take this as equation number 4 and 5, we can easily cancel off these two by reducing 4 minus equation 4 by equation 5. There onwards I can say 4 minus equation 5, and here we cancel these two and subject is alpha as alpha. For that now I can simplify it like this. Alpha squared, I can take alpha squared out, then a squared minus 4 plus 2 lambda a minus 2 equals to 0. Here I will take this step to the right hand side. Alpha squared a squared minus 4 equals minus 2 lambda a minus 2. You know we can simplify this further as a minus 2 and a plus 2. Right? This gives minus 2 lambda a minus 2. A minus 2 cancels with this side. Both sides a minus 2 is cancelled off. Then alpha squared a plus 2 equals minus 2 lambda. Here we can subject alpha squared. This gives minus 2 lambda divided by a plus 2. In this case also we know the denominator. In the denominator it is shown as a plus 2. This means that a can never be equal to plus or minus 2. So once we know that we have two expressions related to alpha. and we have another expression as alpha here. What is the relationship between this alpha and alpha squared? Once you square this expression and you similarize or equalize it to this expression, you can get a certain relationship, and by simplifying that relationship you can find the exact value for alpha, whether it is negative 2 or whether it is positive 2. We need to clarify correctly whether it is negative or positive. So we know that once we alpha into 2 is equal to this alpha square. Now this separate alpha was found out before. What is it? It is minus lambda 2 plus a. Minus lambda 2 plus a whole thing squared, right? Out of the bracket is this power 2. So alpha squared, general term alpha squared was found in here. So directly substitute that. Of course, no need to square it because it's the original alpha squared term. And once you simplify this, you get lambda squared 2 plus a. You get 2 plus a into 2 plus a equals minus 2 lambda 2 plus a. This cancels off with one of these, and then this lambda cancels off with this lambda, and downwards we can say lambda equals minus 2 plus a, that's all, and then we can say that lambda equals minus 4 minus 2a. Here we can say that once we consider, once we take this whole thing separately and equalize it to 0, we can say it's 4 minus 2 alpha. That means alpha equals to 2. So finally we obtain an answer as alpha is equal to 2. Let's see what they mention next in the question. We indeed showed that alpha is equal to 2. Here we already know that a does not equal, is never equal to positive or negative 2. And further show that the quadratic equation f of x equals 0 and g of x equal to 0 have real roots. Further, we need to show that these have real roots as well. For that, first we'll have to consider each at a time. That first we'll look at f of x equal to 0. I'll use another color because we are going to move in forwards each step by step. And the first part or the first sentence was cleared up. I will move on to another color. Here, first we'll look at f of x. What was our f of x? F of x was, as before, initially it was given as ax squared plus 4x plus 2 lambda. And now, since we need to find the discriminant of this, before that we found the expression for lambda earlier, right? What was that? It was this. This is what we got for lambda. This is the additional information we got. From there onwards we continue to build up an expression and find alpha. So we'll have to substitute this lambda in this, in here. So I'll keep so we can see it. F of x equals ax squared plus 4x plus 2 lambda, in the sense it is this whole thing, minus 2 plus a. Once you simplify this again, ax squared plus 4x plus, not plus, right? It's not a plus here, it's a minus 4. Minus 4 fx was what? Fx was 2 lambda, right? Fx was 2 lambda. 4a plus 2. Afterwards, what will be our discriminant now? Our discriminant would be, now this one what I did was I multiplied this by this and made another expression, a new expression with a in it, because lambda was an unknown term and we had to find it using a. Now everywhere we have only a as an unknown term along with x. Now we'll find the discriminant. Discriminant 1 we'll use 1 or fx if you want, because we have two expressions as fx and gx. So our discriminant for fx would be equaling, we know it's b squared minus 4ac. b squared is 4 squared would be 16, and then I write it separately. 4 squared minus 4a minus in a 4a and the c, 4ac. c is this but whole thing, that is minus 4a plus 2. Then once you simplify this, 16 minus 16 will take x squared out, that will be 1 plus a squared plus 2a once you simplify this. Then you can simplify this further as a plus 1 squared. You will get this whole thing simplified. So from there onwards you can come to a conclusion that discriminant 1 is equal or greater than 0, hence a has to be real, and afterwards we can verify the fact that the equation fx has real roots, because it was positive. Now that it is already positive, this is the main thing to be satisfied, like the basic theory that satisfies when the roots are real. So what we again need to prove is that fx has real roots. Now we can clarify, because lambda 1 is equal or greater than 0, hence fx has real roots, right? Now we'll move on to our gx also, because they ask for both gx as well as for fx. And now that we've finished with fx, we'll start with gx now. Gx, what was our initial gx expression? Our gx was this, x squared plus ax plus lambda. X squared plus ax plus lambda. And now again we have to substitute that lambda, what we substituted before for lambda has to be substituted in this expression as well. X squared plus ax. What was our lambda? Lambda was minus 2 plus a. Minus 2 plus a. So afterwards we can simplify this. No need to simplify this further, keep it as like this. And now now we better use the second discriminant for gx. Now we'll use it as discriminant 2. Now second discriminant for gx will be b squared minus 4ac. B squared is this a, that will be a squared minus 4ac minus 4. Here its coefficient is 1. AC in the sense is a minus 2 and 2 plus a. So it further simplified, a squared plus 8a plus 16. So further it will be a plus 4 whole thing squared. Now that again, since this is positive, obviously positive, that means lambda discriminant for gx, delta 2 is equal or greater than, both equal or greater than, not only greater than, you need to use this equal sign as well for real and positive roots. Hence this is greater than or equal to 0. This is the basic theory behind this. Hence a is a real value. And now that gx has real roots, now that it's also complete. Now we better move on to our question. Now we indeed proved or showed that these two have real roots. Now they say let minus 1 be less than a and a be less than 0. If the other roots of f of x equal to 0 and g of x equal to 0 are beta and gamma respectively, find beta. Before moving forward, it better clarify what they mean in here. Now if they say now our common root was alpha. Now they say for fx other than alpha there is another root named beta. For gx other than alpha there is another root named gamma. So using these two principles, these two variables, we can create new expressions relating with roots in terms of alpha, beta, gamma. Right, and finally we'll have to find beta in terms of gamma, find beta and gamma in terms of a. That's what they ask finally. So we'll proceed. And now that our f of x was developed into this is our f of x, this is our f of x, and our g of x, a new g of x is this one. Our new g of x is this one, and then we'll proceed with f of x as we did before. It was as ax squared plus 4x minus 4a plus lambda equals 0. Here we obviously knew that, I already told you guys that the two roots were alpha and beta. Later they said that there's a new root named beta other than alpha. And then again we know according to the quadratic functions basic theories, the relationships between roots can be expressed as a sum of alpha and beta, as a sum of roots. Alpha plus beta, it says minus b over a. Minus b, here coefficient is 4, it will be minus 4 over a. And then the product of roots, alpha beta product would be c over a. It is not a minus, so we should directly input this. So it would be minus 4a plus 2 over a. But what they ask is a relationship between beta with a. So we'll direct, no need of this one, but as we basically write both the sum and the product together, what we really need right now is to subject this beta. That is minus 4 divided by a. We know the value of alpha as we found earlier, it was 2. It will be minus 2. Next, move on to gx. What was our gx? Gx was x squared plus x minus 2 plus 2 into 2 plus a. So we'll move to gx as well. Proceed. Gx was x squared plus x minus 2, a plus 2 equals to 0. Here gx is what is represented by this. Other than alpha, there's another root named gamma. So the sum of the relationship related to sum of the roots will be alpha plus gamma, be equal to minus of the middle term. That is minus n, there's no coefficient, it's just 1. So no need to write it. So subject gamma. So there's gamma in terms of a as well. So minus a minus alpha. Alpha we already know it's 2. So minus 2. You can write it as minus a plus 2. Okay. So now we fulfill that part as well. Because that's where they ask find beta and gamma in terms of a. Only a has to exist as an unknown term when finding the expression for beta and gamma separately. Since we already found alpha, we will easily able to substitute for 2 as the alpha. Next, show that the quadratic equation whose roots are beta over modulus of alpha minus beta and gamma minus modulus of alpha minus gamma. Thereby, let the final quadratic equation be something like this. Okay, so we'll build up the relationships between roots and try to simplify them further. So how are we going to find alpha minus beta? So before using the roots whole thing directly, we'll have to first clearly verify what actually is alpha minus beta modulus is. So alpha minus beta modulus, what is it? So since it's the next part and not related to previous part, I will use another color. That would be purple. So here we'll have to very clarify what this alpha minus beta is. Otherwise, whole simplifications will have to be done in the when finding the answer itself, and it would be kind of a tedious process to continue. So we can chunk by chunk simplify the doubts or the major concerns here. The modulus is a major concern here. If you are to simplify this within your calculation itself, it would be a whole mess, and most probably you will get wrong answers at the end, and most probably not even get the final quadratic equation as well. So here alpha minus beta, we know what alpha is, it's 2 minus beta. What did we get for beta? Beta we already found out. That's why they asked us to find what beta is. Initially they gave us a path, they show us a pattern. Literally they give us what they ask us to find will definitely help us in our next steps when they ask other answers. What we have written initially will indeed be helpful to finish off the question. Unless you get answers correctly in your previous steps, your whole question might perhaps get wrong. So beta is minus 4 over a minus 2. Since it's minus beta, this whole thing would be positive. That means it will be 4 over a plus 2, because minus will become a plus. So it will be 4 over a plus 2 whole thing modulus. What you mean by this modulus is it will never be negative. The whole thing is a positive. So 4, I can take 4 over a out with a modulus, and To create a 4, I'll have to add a modulus A plus 1. Plus 1 will help me to create a 4 over A modulus. So we can simplify it like this. And moreover, since they literally give us a condition, do look at the condition. They say that A is between -1 and 0, which means gives us the idea that A should be negative. So what I have done is wrong, because it says A is only positive. It can never be negative if there is modulus. So this is wrong. I'll have to simplify it further or write it like this. -4 over A plus 1. Because the reason is that my A is in between -1 and 0. Next, we have something else similar to that. Rather than now we found this, what this was, and now that we have to clarify what this is as well. That is alpha minus gamma. Alpha minus gamma. Now clarify that in here as well separately, and then proceed. Alpha minus gamma. What is it? Alpha we know 2. Gamma you can see in top of the screen. This is our gamma. Our gamma is this. That is, since it says minus gamma, this minus can be removed. Then it will be like this, something like A plus 2. Since negative is removed, only A plus 2 modulus. Here 4 plus A modulus. No need of modulus because they say -1 less than A less than 0. So this is the answer for those. These are actually answers. These could help us in proceeding with the question. Like these are hints or what we have to substitute for definitely in our next steps. So now our roots, major concerns are the roots that they have given, like the whole expression we need to consider, not only the below part, now that the whole part. There are 2 big roots here, not big. What I meant by being big is that it's in the form of a fraction and in the form of modulus. We have clarified more than 80% of these 2 roots. Now we can just substitute these 2 roots into the way we usually follow when finding the quadratic equation once the roots are provided. I'll simply write down the roots because I won't have to come talk again and again. The 2 roots are, when roots they have given is beta over alpha minus beta modulus gamma over alpha minus gamma modulus. Alpha minus gamma modulus. So the form of the quadratic equation would be we know that it's something like x minus beta modulus alpha minus beta whole thing minus x minus gamma alpha minus gamma modulus whole thing equal to 0. So the form of quadratic equation is x squared initially minus and then the sum of 2 roots. Sum of roots x plus root product. We don't need to write this step in your answer stream, but since this is a kind of a discussion and you can easily revise how to get this equation directly is essential. Now that I'll write it in step by step. and here plus root product equals to 0. No need to write, this is not essential though. X squared sum of roots. Now roots, you know the roots are these, this and these are the roots. Sum of roots would be beta minus alpha minus beta plus gamma, alpha minus gamma, x plus root product beta alpha minus beta into gamma alpha minus gamma whole thing multiplied equal to 0. Okay, this is the format. This is our equation. Then now what you have to do is to simplify this. Okay, how to simplify now? Look carefully. I'll consider this as something lambda and mu like that, because then the simplification will become easier. Then separately I'll simplify lambda, and what I finally get, I will again substitute back into this quadratic equation. And once I again separately simplify this mu, at the end I will substitute what I get to the back into the quadratic equation again at the end. So finally I will get my final quadratic equation in terms of A, right, without alpha, beta, gamma. So here lambda, my lambda is going to be, I will separately write it, alpha minus beta plus gamma alpha minus gamma. Now peacefully simplify this. It is like alpha minus beta into alpha minus gamma. Okay, so beta alpha minus gamma plus gamma alpha minus beta. So once you simplify this again, alpha beta minus okay, no need to simplify. You can simplify it like this using the relationships of roots. I told you how to get the root product initially, though it was not essential, but we'll proceed in the easy way. So I will remove this. Okay, I will remove this as well. Okay, now beta we found out before, right? Can you remember we found out what beta was? Beta was actually minus 4 over A minus 2. That is minus 4 over A minus 2. Alpha minus beta, we found it, right? You can remember it is minus 4 over A. Minus 4 over A plus 1. A plus 1 plus gamma. What plus gamma? That is minus A plus 2. Minus A plus 2. What was alpha minus gamma? That was 4 plus A. That is 4 plus A. Now it's easy, right? You have only the A terms, and once you simplify this, you get 4 minus A squared divided by 2A plus 1, 4 plus A, right? 2 terms here, and do your usual simplification. Now that lambda was found, it's a major leap once you get this answer, and now that you will find out what mu is as well. So it's this should definitely be the product. You see it's the product here. So instead of addition sign, I'll be using the multiplication or the product as a dot, then alpha minus gamma. Here same scenario, we have substitute minus 4 over a minus 2, that again minus 4 over a plus 1 multiplied by minus a plus 2, 4 plus a. Once you multiply this, you get you should be getting a plus 1 and 4 plus a should obviously be in the denominator. Final mu would be a plus 2 squared, 2a plus 1, there should be minus plus 1 and 4 plus a. That is our mu. Now that both mu and lambda are already found out, we can substitute in a general equation. What is our general equation? Now that we directly use lambda and mu, x squared minus lambda x, okay, plus mu equal to 0. This is our major quadratic equation. Lambda and mu are the variables that I named them for the convenience in our simplification without missing it. So again x squared minus lambda. What is our lambda? Substitute this lambda over here. Minus 4 minus a squared, 2a plus 1, 4 plus a. X minus. It's a plus, but because there's a minus here in the mu, I'll write it as like this. Just substitute mu here. A plus 2 squared, 2a plus 1, 4 plus a equals to 0. Finally, in order to create this in the format of a quadratic equation, I'll have to multiply the whole equation with the denominator part, which is common to the both of these sections. That is to directly write the equation. 2 into a plus 1, 4 plus a into x squared plus a squared minus 4 into x minus a plus 2 squared equal to 0. So these are cancelled out once you multiply by the same thing. Top and bottom get cancelled off. So this is our final answer. Okay, so that's what they asked. I think they've given the equation. Let's verify whether this is the one we got at the end. Yes, this is what we got at the end. Now we'll move on to the part B, which comes under remainder theorem. Okay, based on the lesson remainder theorem. That of course we'll discuss it as well. For part B, this whole question comes as bulk in the same question number 11. These are the only two lessons that you will be getting under question number 11 as part A and part B. So now I'll directly move on to the part B. Part B based on remainder theorem. First, let's read the question and understand. Try to understand. Let p of x equal to x to the power 4 plus ax squared plus bx minus 9, where a and b are real. The remainder when p of x is divided by x minus 2 is 3. Okay, stop. Without continuing the whole question, just stop there. Okay, try to verify, try to just include the data points and just write the remainder, the equation relating to, apply the remainder theorem to this particular part and then proceed. Okay, because it's obvious. The remainder when p of x is divided by x minus 2 is 3. They have given the px quadratic equation. Once it is divided by x minus 2, remainder is 3. You got the idea, right? So now we proceed. The p of x is given as I'll continue with a dark color like green, dark green. P of x to the power 4 plus ax squared plus bx minus 9. So what this says, when px divided by x minus 2, remainder is 3, as I could remember. You don't need to write that because I needed to verify it, because I had to go up and down. A and b are real. X minus 2, remainder 3. Okay, we got the data. Now substitute this p when the whole, for this x, once 2 is substituted. Okay, once 2 is, if it's x minus 2, it should be x equals to 2. So once that 2 is subjected as x instead of x, you'll have to insert 2, and then the remainder would finally be 3. Okay, it's not a factor, which means it p of x does not equal to 0. So instead it has a remainder of 3. So write px now including 2 for all the x terms. That means 2 to the power x plus a into 2 to the power 2 plus b power 2 to the power 1 minus 9 equals to 3. That is 4a plus 2b equals to, simplifying this, you get minus 4. That is, once you divide this whole thing by 2, we can further simplify and get 2a plus b equals minus 2. This is the expression I got. So that particular part was done, and we'll proceed with the question again. It says also, okay, now this thing was done. Also it is given that the remainder when p dash x. What is this p dash x mean? We'll see. Well, actually this p dash x is the derivative of the function p of x. Is divided by 2x minus 1 is 5 more than the remainder when p of x, p dash x is divided by 2x plus 1. Okay, what do you get by that? It is given that the remainder when p. First we'll clarify what this p dash x and write down what p dash x is all about. So we'll write down this p dash x. What is p dash x? It is the derivative of px. So derivative of x to the power 4 is 4x cubed. Derivative of 2ax squared is plus 2ax. Derivative of bx is plus b. Okay, that is our p dash x. There are no derivatives for single numerals. And now we'll continue. We know what p dash x is now, and it is divided by 2x minus 1. You'll have to divide it by 2x minus 1. once you divide p dash x divided by 2x minus 1. Okay, so that means p dash x is 1 over 2, because 1 is subject, x is 1 over 2 half, is equal to what? Equal to is divided by 2x minus 1 is 5 more than the remainder when p dash x is divided by 2x plus 1. Once this is, we can write this format like when p dash x is divided by 2x plus 1, you can write it as, once you subject x, it is minus half, right? For this case, it's minus half. So it is 5 more than the remainder when p dash x is divided by 2x plus 1. 2x plus 1 is actually p dash x, substituting with the minus half, and it should have additional 5. This is our remainder for actual p dash x when divided by 2x minus 1. Okay, so just insert it. The remainder will be 5 more than when p dash x is divided by 2x plus 1, that will be minus half. This will be the remainder, right? So just substitute it here like p dash minus half plus 5. Okay, direct, this is what I substitute. Now considering this p dash x, substitute this half for each x term. First we have four into half to the power 3 plus 2a half plus b equals to p dash minus half. What is p dash minus half? That is this. Substitute minus half. 4 minus half into 3 plus 2a minus half plus b plus another 5. You should simplify this. So in this case, it is 8, that means a half plus this cancels off with this a plus b equals to minus half, this cancels off, minus a plus b plus 5. Here again b to b cancels off, and then a to a, you get 2a, then this goes here as minus half, then it becomes a 6, then 2a, finally you get that a equals to 2. Once you get this a equals to 2, its minus 1 becomes a 4 now, so then a equals to 2. Then substitute in what we got before. We got an expression earlier as expression 1. We got 2a plus b equals, according to expression 1, we got 2a plus b equals to minus 2, as you saw here. Okay, 2a plus b equals to minus 2. Here a equals to 2. Substitute a equals to 2 is 4. Plus b equals minus 2, b equals minus 6. Okay, minus 6. And then we did find what a and b are. The values of a and b are 2 and minus 6. We proceed. Find the values of a and b. We found them. We already found them. Next, let q of x be equal to 4px minus xp dash x plus 34 for these values of a and b. Let. Now they give another expression. First, let's verify again the px and p dash x by substituting a and b. Here you see now our px was given in terms of a and b. Now that we found a and b values, directly substitute and write this px again separately. And for px separately as well, p dash x as for p dash x as well, removing a and b variables and substituting the actual values for both a and b. So again, verify that what actual quadratic function px is. Px is actually x squared, x to the power 4 plus 2x squared. X to the power 4 plus ax squared. Ax squared, actually a was 2 and x squared. Plus bx minus 9. Actual value of bx is minus 6x. Minus 6x minus 9. Now what p dash x is? What is our p dash x? You can directly get it from here by deriving each of these terms. 4x, that would be 4x cubed plus 4x minus 6, right? No need to look at what the p dash x we got before, but because you can directly derive it in here itself. Now that they have given us a separate expression as qx equals 4px minus xp dash x plus 34. Write that down separately and then we'll simplify. I will simplify it as what they have given is qx 4px minus xp dash x plus 34. Now what is we have px and we have p dash x. Now continue simplifying. 4 into px. What is px now? Px we have it here. X to the power 4 plus 2x squared minus 6x minus 9 minus x into p dash x. P dash x is here. 4x cubed plus 4x minus 6 plus 34. Now plus 34, yes, this 34 is this. Now you further simplify this. There you get 4x squared plus 8x squared minus 24x minus 36 minus x 4x cubed plus 4x minus 6 plus 34. So if you further simplify this, you will be getting an answer like 4x squared minus 18x minus 2 is your final expression for qx, capital Qx. Okay, now we'll again go back to the question and see. For the values in a, b, let qx equals, and show that now that is completed. We did simplify this. Show that the remainder when p dash x is divided by qx is 3 into 29x plus 1. Remainder when pa dash x is divided by qx. P dash x divided by qx, okay. So now that when p dash x is divided by qx, what is when p dash x divided by qx? You can write it as p dash x, we know it 4x cubed plus 4x minus 6 equals q dash x we got 4x squared minus 18x minus 2. They are asking us the remainder, right? They haven't given any. Show that the remainder is this one. That's a particular remainder that we are to find out. That remainder, the way we are going to express the remainder is that since this major function p dash x has a power 3, and here what it is divided by has a power 2, but the extra power we need is x to the power 1 in order to create this x to the power 3. For that we should create an extra x to power something unknown term k plus something lambda x plus mu like something. Okay, now we'll equalize by equaling the coefficient of powers. We'll use x squared terms here. There aren't any x squared terms since it's 0. Here x squared terms we have 4 and 18k. X here 18k, 4k minus 18, and 4k you get 9 over 2. And similarly for x also, by equaling powers of coefficient of powers for x to the power 1, you get here for x term you have 4 equals minus 18k minus 2 plus lambda. Here you lambda, the value you get is 87. And for x to the power 0, so you can use the same scenario. I have minus 6 and equal it to the other side, minus 2k plus mu you get 3. And finally the remainder we wrote down is lambda x plus mu. No? So lambda, the value of lambda we got is 87x plus mu is 3. That would be, once you take 3 out, you get 29x plus 1 as the remainder. That was a bit complicated. Other than that, the rest of this question is marks can easily be achieved without any extra effort. So that of course we completed for the whole question, I think. Yes, we did indeed complete everything in this question. This is a nice question that covers basically all the theory concepts in an advanced way, including the modulus. That's the specialty about this question, similar to the years like 2022, as I can remember. So thank you very much for listening and understanding. But first attempt into this question and then watch the discussion step by step and clarify all your doubts. So thank you for watching. Have a nice day.